A triangle has a base of a length 15 centimeters and a perpendicular height of 12 centimeters. Calculate the area of the triangle. Well, we know from our formula book that the area of a triangle is half times base times height, with the height being the perpendicular height. So we have a base of 15, a height of 12, so half times 15 times 12 is 90 centimeters squared. We have another formula in our formula tables for the area of a triangle, and it is half AB sine C. In a triangle PQR, so PQR, PQ is 7 centimeters, so PQ is 7 centimeters. QR is 9 centimeters, so QR is 9 centimeters. And the angle PQR is 48 degrees. PQR 48 degrees. Find the area of the triangle, correct 2 decimal places. So we can always rename the sides and angles to suit ourselves. So since there is a capital C in our formula, half AB sine C, we're going to label the angle that we're given as a capital C. So Q is now C. The side that's opposite that we label as lowercase c. So the side PR we label as C. Then the other two sides we label as A and B. It doesn't matter which way we label them. So I'm going to label PQ as A and QR as B. So I let PQ be A, QR be B, and then angle C is 48 degrees. Then using our formula, half AB sine C, we swap the A for 7 with brackets around it. We swap the B for 9 with brackets around it. And we swap sine C for sine of 48 degrees. Into the calculator, we get 23.409, and to 2 decimal places, we get 23.41 centimeters squared. Suppose we are given the area of a triangle and asked to calculate the angle between the two given sides. Then, because sine is positive in the first and second quadrants, there will be 2 possible angles. If the first acute solution is 34 degrees, then the second obtuse solution is 180 minus 34 degrees, which is 146, and so on. This is called the ambiguous case, and can occur any time sine is being used to find an angle within a triangle. So let's have a look at an example. In the triangle MNP, so MNP, MNP, MP is 12 centimeters, so MP is 12 centimeters, or MP is 12 centimeters. NP is 17 centimeters, so NP is 17 centimeters, NP is 17 centimeters. So these sketches would not be given to you in the question. If the area of the triangle MNP is 83.55 centimeters squared, find the 2 possible values for the angle MPN. So MPN, so we're trying to figure out what this angle could be, MPN. Giving your answers correct to the nearest degree, and then draw the 2 possible triangles. So we're going to draw out a triangle and another triangle, one with an acute angle, one with an obtuse angle. We let A equal MP, we let B equal NP, and C equal the angle MPN. We know the area is equal to 83.55. We're going to swap the area for the actual formula, so we get a half AB sine C equals 83.55. We swap the A for MP, which we were told is 12 with brackets around it. We swap the B for NP, which we were told is 17 with brackets around it. And we don't know what the angle is, so we have sine C and equal to 83.55. We multiply out the brackets. A half times 12 times 17 is 102. Let's get 102 sine C equals 83.55. And then we divide across by 102. And 83.55 divided by 102 is 0.8191 to 4 decimal places. And since we're looking for the angle, we have to use the inverse function. So the inverse function of sine. So we press the shift button, second function button, and we put 0.8191 into the brackets. And we'll end up with 55 degrees rounded off to the nearest degree. So 55 degrees is one possible angle. And then 180 take away 55 is 125 degrees is the other possible angle. So the acute angle is 55 degrees and the obtuse angle is 125 degrees. So the two possible triangles are shown. So we have one triangle with an acute angle labelled 55 degrees. PM we label as 12, PN we label as 17. And then we have our other triangle with our obtuse angle being 125 degrees, and PM being 12 and PN being 17.